September 28, 2018, early morning. Air Niugini Flight 73 departed from Pohnpei International Airport. The flight had a planned stopover at Chuuk before continuing on to its final destination, Port Moresby. On board the aircraft were 12 crew members and 35 passengers. The plane carried 30,000 pounds of fuel, enough to fly directly to Port Moresby without needing to refuel at Chuuk. Flight 73 was commanded by a 52-year-old captain with nearly 20,000 total flight hours. The co-pilot, a 35-year-old Australian, had 4,600 flight hours. The aircraft was a Boeing 737-800, built in 2005. It had previously served with Air India Express and Jet Airways. Ownership of the aircraft belonged to a company based in Iceland, which leased it to Air Niugini. Under the lease agreement, the lessor required one of their aircraft maintenance engineers to travel on all flights outside Papua New Guinea. On Flight 73, this engineer was seated on a jump seat behind the cockpit. Out of personal interest, he used his mobile phone to record the entire flight. This Boeing 737 was unique within the fleet because it was the only aircraft equipped with an integrated enhanced navigation system. The main purpose of this system was to provide visual guidance. It displayed whether the aircraft was deviating from its intended path through two magenta diamond-shaped markers. If the aircraft went off course, the diamonds would move up, down, left, or right. Without this system, pilots would not see such visual cues when performing area navigation approaches, RNAV. Flight 73, during this flight, was using a non-precision RNAV approach. Since this was the only aircraft in the fleet with the system, the airline had never planned to activate the feature. Although there were plans to remove it, this was never carried out. As a result, the system remained operational, but the pilots had never received training on how to use it. This represented a serious oversight. The flight segment to Chuuk was only 380 miles long. At a cruising altitude of 40,000 feet, the time required for climb and descent meant the total flight time would be less than an hour. During this short trip, the crew spent only a few minutes in cruise before beginning preparations for the approach procedure. To obtain the most accurate landing performance data, the first officer used an application called the Operational Performance Tool, OPT. This app was installed on the airline-issued Electronic Flight Bag, EFB. By entering the current weather conditions and the estimated landing weight, the first officer calculated the approach speeds and the minimum runway length required for different flap settings. Based on the results, the two pilots decided to set the landing flaps at 40 degrees, which would reduce the required landing distance by about 500 feet. Although 500 feet may not seem significant for a jet aircraft, on many Pacific Island runways, built on atolls or small islands with very limited land, this difference could be critical. Chuuk Airport's runway is only 6,000 feet long. A Boeing 737-800 typically requires between 3,500 and 5,000 feet to land, depending on its weight. In addition, Chuuk's runway does not have a runway end safety area, a buffer zone designed to slow down an aircraft if it overruns the runway. Taken together, these factors meant that when landing at such airports, pilots had to be extremely precise, and minimizing the landing roll distance was a key consideration in flight operations. To prepare for arrival, the crew began discussing the RNAV, Area Navigation, Non-Precision Approach for Runway 04 at Chuuk Airport. Flight 73 approached from the east, first flying over the Macno waypoint toward Kari, then turning toward PSAP, crossing it at 2,500 feet and intercepting the final approach path for runway 04. The aircraft would then pass over Festival, with the final approach fix, FAF, at an altitude of 1,700 feet. The last waypoint before the runway was the missed approach point, mapped. At Hemis, the minimum descent altitude was 420 feet. The missed approach point is critical in any approach. Before continuing beyond this point, the pilots must clearly see the runway while maintaining a stabilized approach. If the runway is not visible, they are required to execute a go-around procedure. If a pilot continues descending or strays off the approach path without having the runway in sight, the aircraft and everyone on board would face serious danger. Because this RNAV approach did not provide a defined vertical glide path, the crew of Flight 73 could only rely on the Flight Management System, FMS, to compute descent guidance. This meant the autopilot could not fully handle the final phase, and the pilots had to fly manually after the mapped. This not only increased the pilot's workload, but also greatly raised the risk of deviation from the standard approach path. When briefly reviewing the go-around procedure, the captain failed to specify the exact missed approach routing. The briefing also did not cover all items required by the airline's standard operating procedures, SOPs. This suggested that the captain may have already made up his mind in the early stages of the approach to land at all costs, completely disregarding the possibility of a go-around. Such a reckless attitude, ignoring proper procedures, meant the crew was effectively placing all passengers' safety at risk. 35 minutes after takeoff, Flight 73 began its descent from cruising altitude and requested weather information for Chuuk Airport from air traffic control. The controller reported winds 5 knots, visibility 14 miles, scattered clouds at 1,200 feet, a broken cloud layer at 12,000 feet. Cumulus clouds form when warm, moist air rises and cools at higher altitudes, causing condensation. These clouds are very common in the tropics and equatorial regions, especially around Pacific Islands. As cumulus clouds continue to grow vertically, they can develop into intense thunderstorm clouds, bringing heavy rain, hail, and severe turbulence. For this reason, pilots generally try to avoid flying into or near cumulus cloud formations. As the aircraft continued descending, the first officer regularly reported its position to ATC. At 8,000 feet, he switched to Chuuk's local frequency and broadcast the aircraft's approach intentions. Because the region has very low air traffic, Chuuk Airport does not have an active control tower. Pilots instead rely on a common traffic frequency, listening in and coordinating directly to avoid mid-air collisions. In the cabin, the flight attendants completed their final checks, making sure all passengers were seated with seatbelts fastened and prepared for landing. At this point, everything during descent seemed normal. Neither the captain nor the first officer anticipated the crisis about to unfold. As the aircraft approached the Nipop waypoint and descended through 4,000 feet, the captain began briefing the missed approach procedure. However, he stopped midway through and never completed the briefing. The first officer did not respond or ask why, and as a result, the missed approach procedure was completely omitted from the approach briefing. At 9:20 a.m. local time, Flight 73 continued its descent, passing through 2,300 feet and turning to a heading of 041 degrees, lining up with the final approach for runway 04. The captain verbally confirmed that the aircraft was executing the RNAV approach procedure and was properly aligned with the runway. He then told the first officer that he would continue the approach down to 1,000 feet. The first officer broadcast this information over the common traffic frequency. The aircraft then extended its landing gear and the flaps were set to 15 degrees. The first officer reported that rain was falling near the airport, the first signs that Flight 73 was entering the cumulus cloud activity previously mentioned in the early ATC weather report. On the navigation display, the aircraft's weather radar showed several red areas, a clear warning of intense thunderstorm cells. Despite the first officer's reminder, the captain remarked that the storm would soon pass and chose to continue the approach. The captain then told the first officer, "I'll just follow the poppy lights down." The Precision Approach Path Indicator, or PAPI, is a system of lights installed beside the runway, usually just beyond the threshold. It helps pilots maintain the correct vertical descent angle. On final approach, pilots see 4 lights. If on the correct glide path, 2 white and 2 red. If too high, 4 white lights. If too low, 4 red lights. Inside the cockpit, The captain instructed the flaps to be set to 40 degrees and told the first officer to complete the landing checklist. At this point, the aircraft descended through 1,000 feet above ground level, and the automated call-out sounded in the cockpit. According to company procedures, the first officer was required to confirm that the aircraft was on the correct glide path, the approach speed matched the calculated landing speed, and all criteria for a stabilized approach were satisfied. About 100 feet lower, the aircraft broke through the clouds, and the crew finally had visual contact with the runway. The aircraft was properly configured and everything appeared normal. The pilots prepared to land. About a minute later, descending through 600 feet, the captain noticed the aircraft was slightly above the glide path. As they neared the missed approach point, Map taught, he disengaged the autopilot and gently pushed the control column forward, lowering the nose to realign with the correct descent angle. At that moment, sheets of rain swept across the windshield, suddenly blocking all forward visibility. The aircraft had entered a thunderstorm cell, exactly where the navigation display had earlier shown red warning zones. Determined to regain the glide path and land, the captain ordered the first officer to switch on the windshield wipers, then continued flying into the heavy rain. The first officer looked outside and said he saw 3 white lights and 1 red light on the PAPI system, a clear indication that the aircraft was too high on approach. This reinforced the captain's belief that he needed to push the aircraft further down to recapture the glide slope. As the aircraft descended below the minimum descent altitude, the cockpit warning system called out minimums, but the runway had already disappeared back into the clouds. According to procedures, this situation required an immediate go-around. Continuing below MDA without runway in sight was not only a violation of company regulations, but also a serious threat to the safety of everyone on board, because the pilots had lost reliable visual reference to judge the aircraft's height above the ground. Although the aircraft had already entered Instrument Meteorological Conditions (IMC), the crew of Flight 73 decided to continue the approach, focusing all their attention on chasing the glide path and attempting to land at Chuuk Airport. In order to recapture the glide path, the aircraft's descent angle was steepened from the standard 3 degrees to 4.5 degrees. While this adjustment helped realign the aircraft with the intended path, it carried the risk of serious, even fatal consequences. Sensing the hazardous descent rate, the aircraft's Enhanced Ground Proximity Warning System, EGPWS, issued a cockpit sink rate warning. This system is designed specifically to monitor the aircraft's vertical descent rate. Whenever the descent exceeds 1,000 feet per minute at altitudes below 2,500 feet, the system generates an alert. Such warnings must be taken very seriously. Company procedures required that if a warning occurred during an approach, the pilots were to immediately execute a go-around. Despite this, the captain gave only a brief verbal acknowledgement of the alarm. He remained intent on rejoining the glide path, taking no corrective action. At this moment, the aircraft was only 500 feet above the ground and still descending rapidly, losing about 125 feet every 2 seconds. Then another glide path warning cut through the tense atmosphere of the cockpit. The magenta diamond indicators we mentioned earlier slid almost to the very top of the display as the aircraft continued descending, signaling that the airplane was now far below the ideal glide path. The system was trying to alert the pilots to this severe deviation, but because the crew had never been properly trained on the system and had grown accustomed to frequent false alarms, they had learned to habitually ignore its warnings. As a last line of defense, a prominent red "pull up" warning appeared at the bottom of both pilots' primary flight displays, instructing them to immediately halt the descent and climb away. Yet even when faced with this red alert and a chorus of audio warnings, the captain maintained the same rate of descent. He told the first officer, "I just want to go down a little more." Why would such an experienced captain ignore all safety warnings and persist with this dangerous approach? This was the result of a psychological phenomenon known as plan continuation bias, also called tunnel vision. Once the captain had mentally committed to landing, he became fixated on that single goal, focusing entirely on continuing the approach and disregarding all external warnings and cues from the environment and systems. This mindset ultimately led to catastrophic consequences. When the crew finally realized that the aircraft was only 100 feet above the water, the cockpit filled with overlapping alarms. The first officer, now clearly anxious, suddenly asked the captain, "Do you see the runway?" Although the captain answered, "Yes, I see it," the first officer's view was still filled with thick white cloud. Just seconds later, the horrifying moment arrived. The turquoise waters of the lagoon suddenly appeared beneath the nose of the aircraft. The first officer screamed repeatedly, "Too low, we're too low." But by then, it was already too late. Flight 73 struck the waters of the Pacific Ocean less than 1 mile from Chuuk Airport. The aircraft hit the surface multiple times before slowing down, nearly rotating 180 degrees and finally coming to rest about 500 feet short of the runway threshold. Rescue boats from the local government, private operators, and U.S. Navy divers stationed on the island quickly arrived at the crash site to search for survivors. After a brief rescue operation, all but one passenger were successfully saved. That missing passenger was later found inside the cabin during an underwater search 3 days later. The investigation revealed he had not fastened his seatbelt during the impact, which caused severe injuries that prevented him from escaping before the aircraft sank. The accident investigation determined that along the published missed approach path, there had been no hazardous weather. If the pilots had executed a missed approach at the minimum descent altitude as required, they could have easily avoided the thunderstorm cell that caused the accident and prevented the tragedy. In the final seconds, the aircraft's rapidly increasing descent rate showed that the captain was completely fixated on regaining the glide path and determined to land, even after losing visual contact with the runway. In post-accident interviews, the first officer admitted that although the weather radar had clearly displayed storm activity, the sudden heavy rainfall still caught them off guard. This supported investigators' suspicion that the crew, in their fixation on landing, had lost situational awareness of their environment. Investigators also reviewed flight records from the day before the accident and discovered that the same crew, on approach into Pohnpei Airport, had flown consistently below the glide path, ignoring a total of 28 glide path warnings. Although the final accident report did not officially list this normalization of deviation as a direct cause, it is reasonable to conclude that this habitual disregard for system warnings likely played a critical role in the fate of Air Niugini Flight 73.